Hello dear friends, I am Dr. Meenakshi Rathi and I am going to deal with the SYBSc paper 2, that is CH 402 semester 4 second term inorganic and organic chemistry. The syllabus of first term was molecular and orbital theory of covalent bonding, introduction to coordination chemistry, aromatic hydrocarbons, alkyl and aryl halides, and alcohol, phenols and ethers. This part you already studied in semester 1, that is paper CH 302, but I am going to deal with the paper CH 402 inorganic and organic chemistry, that is semester 4 second term paper, and in this we are going to discuss total 7 chapters. The first one is isomerism in coordination complexes, valence bond theory of coordination compound, crystal field theory, aldehyde and ketones, carboxylic acids and their derivatives, amines and diazonium salts, and the last one it is stereochemistry of cyclohexane. So there are total 7 chapters we will discuss for the second term. Out of these, the first 3 chapters, these are the part of inorganic chemistry, while next 4 chapters, these are the part of organic chemistry. Now, before starting the actual chapter, isomerism in coordination complexes, I just want to take the revision which you already studied in first term, that is introduction to coordination chemistry. We will took the little introduction and then we will start the actual chapter isomerism in coordination complexes. So first we'll see what do you mean by coordination. Now in coordination compound there are two parts, one is a metal and another is a ligand. And ligands, they have lone pair of electron, while metals they have empty orbitals. So when an orbital from a ligand with lone pairs in it overlap with an empty orbital of a metal, there is a formation of bond between metal and ligand. That bond is represented like this. Arrow is shown from ligand to metal because ligands they carry lone pair of electron, and those lone pair of electrons are donated to the empty orbitals of metal. That bond is called as coordinate covalent bond. So ligands with lone pair of electron donate to the empty orbital of metal, and metal ligand coordinate covalent bond is formed. That phenomenon is called as coordination. Here one example is taken. When there is a bond between metal and ligand is formed, it is based on the Lewis acid and Lewis base. This bond formation, it is always between the Lewis acid and Lewis base because the ligands have lone pair of electron or non-bonding electron, and hence these are called as Lewis bases, and the metal ions, they have empty orbitals. They can accept these lone pair of electron, and hence these are called as Lewis acids. So when Lewis acids and Lewis bases, they form a bond, that is also called as a coordinate covalent bond. Here in this example you can see silver metal ion is there and ammonia there is a lone pair of electron present on nitrogen. Two molecules of ammonia, they donate their lone pair of electron to silver, and there is a formation of coordinate covalent bond. This is called as coordination compound or complex. The geometries of coordination compounds, especially for metals, there are two common geometries for metals with coordination number 4. One is tetrahedral, which is represented here, and another is square planar. Both these geometries, they have the coordination number 4. So the common geometries for metal with coordination number 4 are tetrahedral, which is shown here, and the square planar. While when the coordination number is 6, the most encountered geometry, it is the octahedral. In this example, you can see cobalt, it is attached to the 6 ammonia molecule, and hence its coordination number is 6. And the geometry for this compound, hexaamine cobalt, it is a octahedral, which can be represented like this, or it can be represented like this also. So what we had said, if coordination number is 4, then the geometry is either tetrahedral or square planar. But when coordination number is 6, the geometry, the most encountered geometry, it is a octahedral. Now there are different types of ligands present. First we will see, what do you mean by polydentate ligand? Sometimes ligands have 2 or more donor atoms. In this example, you can see cobalt, it is attached to the 3 molecules of ethylene diamine. And ethylene diamine, here ethylene diamine, it has 2 nitrogen atoms, and both the nitrogen atoms are a donor atom here. And that's why ethylene diamine, when it acts as a ligand, it is called as a bidentate ligand, because in ethylene diamine, both the nitrogen atoms, these are the donor atom, and hence it is called as a bidentate ligand. If more than 2 donor atoms are there, then they are also called as polydentate ligands, or these are also called as chelating agents. Another example of polydentate ligand, it is ethylene diamine tetraacetate, which is commonly known as EDTA, and this is the structure of EDTA. Here in this EDTA, you can see there are 6 donor atoms, 4 oxygen atoms, and 2 nitrogen. So which is simply represented, EDTA is simply represented like this. It has 6 donor atoms. So EDTA is also called as a polydentate ligand. And this EDTA, in this example you can see cobalt, it is a central metal ion, and to this central metal ion, EDTA, which has a 6 donor atom, it wraps around the central metal ion like an octopus. You can see here. So EDTA, it is a polydentate ligand. Now nomenclature of coordination compound. Actually this part you already studied in first term, but it's just a revision. Whenever we give the names to the coordination compound, we need to find out the 2 parts in the complex. One is, which one is the cation part and which one is anion. For example, in this case, pentaamine chlorocobalt chloride, this part, it is a cation part, and this chloride ion, which are written outside the square bracket, this is the anion part. And whenever name is written for the coordination compound, the name of cation appears first the anion is named last. So, for this compound, the name is, and now in this example, you can see cobalt is a central metal ion, while there are two types of ligands, one is amine and one is chloride. So, in amine and chloride, alphabetically if you see, A comes first and C comes later. Don't think about the prefixes like mono, di, tri, penta. Whenever you decide the alphabetical sequence, you just need to see the name of the ligand only. So here, amine and chloride, A comes first. So we are writing the name pentaamine chlorocobalt chloride. Because pentaamine chlorocobalt is a cation, so it is written first, and chloride is the anion, so it is named last. So, and here, if ligands are negative or anionic ligands are there, then it ends with O, like chloride. It is a negative ligand. So it is named chloro. It ends with O. While amine, it is a neutral ligand. So their name is written as it is, amine. Their name is not changed. And the prefix which we are using here, like bis, tris, penta, it just tells the number of type of ligands present in the complex. So penta, it indicates that 5 ligands of amine are attached to the cobalt. Now the nomenclature of anion, if the complex is anion, for example take this, here there are two parts, sodium is a cation part while the remaining it is the anion part. That means complex itself it is the anion. So when we write down the name, it ends with the ATE, and as usual cations are named first and anions are named last. So here the name it becomes sodium tetrachloro oxomolybdate. Here metal, its end it changed and it is named as a ATE. Molybdenum, it becomes molybdate, and at the end this number 4, it indicates the oxidation number of the metal. Here are some examples of the ligand and how their name get changed in the complexes. These are given. The basic protocol in coordination nomenclature is to name the ligand attached to the metal as prefix before the metal name. Before the metal name, ligands are named and their spellings get changed as per this table. Azide become azido because it's a negative, anionic ligand. Bromide becomes bromo, chloro, cyano, fluoro, like this. And if neutral ligands are there, then their name is remain as it is. Especially ammonia, it becomes amine. Carbon monoxide, it is called as carbonyl, and water, it is called as aqua. So here we have finished the introductory part or some basic revision of coordination complexes. In next video, we will start with the actual syllabus of second semester.